Okay, welcome back. So you have played around with the position and the direction, and you hopefully have um, Bilbo in the middle of the screen facing straight up. Now, something I forgot to say in the last video is I would like for him to be facing straight up towards the top of the screen, and then I also want you to get the ring, the target, to be directly in front of him. So I want Bilbo, hopefully you've already got him in the middle, facing straight north, and then I want the ring right above him. So you want to play with the ring is the target, so you want to play with its X and Y. Its direction does not matter because I don't really care which way the ring is looking. I just want him to be right above Bilbo. So I'm going to pause this. I want you to pause the video for a second so that you can make sure your ring is directly above in front of Bilbo. So pause the video and get that rigged up. Okay, so we're back. So you've got the ring in the right spot. You've got Bilbo in the right spot. You've got Bilbo facing the ring. Very exciting. What we need to do now is talk about math. So we need to get Bilbo to move. Now, when we were dealing with who's that other dude? Mario. When we were dealing with Mario, all you worried about was add to his X makes him move horizontally, add to his Y makes him move vertically. Now, Bilbo's a little more complicated because he has some direction that he's got to be facing, right? So we're going to talk about angles. So think about this angle that he's facing. We're going to call it T, which really it's player dir, but we're going to call it T because I didn't want to type player dir. Now, all those moments when you were doing SOHCAHTOA in geometry class, it's all going to pay off right now because you've got to deal with some geometry. Because here's what's really strange. In Java, there is no diagonal movement. There's no such thing as like following this blue line. There is no diagonal movement. Every diagonal movement is actually, you're going to think about it as a horizontal movement and a vertical movement together that make it look like you move diagonally, but really you're going to move to the right, follow and up before somebody looks at you again, right? And then that will make them look like you went diagonal. So if you were standing if you were standing here, right, down here in this corner, and I closed my eyes, and then you were to move to the right a certain amount and up a certain amount before I opened my eyes, it would look to me like you moved diagonally. Now, Bilbo has some speed that he wants to move. So if you wanted to move 15 pixels, if you want the diagonal to be 15 pixels, that's your hypotenuse. So here comes your right triangle business. Now don't forget, SOHCAHTOA, or my geometry teacher said, some old hippie caught another hippie tripping on acid, because I could never remember how to spell SOHCAHTOA, because it's not a word. So, some old hippie caught another old hippie tripping on acid, is what my geometry teacher used to say. Her words of wisdom. Now, so for example, the cosine is caught another hippie. So cosine equals opposite. Sorry, I just lied. Caught another hippie. Now I can't spell. Cosine is adjacent over hypotenuse. So if you're going to be talking about the cosine of this angle, you've got your adjacent here, which is this mystery. I don't know how many pixels this is, over your hypotenuse, which is the thing I know I want him to go 15 pixels, right? So this is something I don't know. Now this angle, I do know the angle. I do know that I want to go 15. The big mystery is this dx. What horizontal change do I want to make this happen? So the 15 is known, the angle is known, the dx is not. So all you need to do, rearrange this to get your dx by itself. Now I'm going to try to write with the mouse, don't judge me. If I want to get my dx to be all by itself, I just need to multiply both sides by 15. Ooh, yeah, nice. So I'm going to multiply this side by 15. That just gives me something beautiful. Now I've got my 15 times the cosine of t is equal to dx. Now I could figure out exactly what this is. Now you're going to do the exact same trick with dy. If you want to figure out how much you want to change vertically, then you're just going to do almost the same thing, except for cosine has nothing to do with that because that's the opposite, so you're going to have it rigged up to be sine. So the only difference if you're going to be dealing with dy is that your dy is going to equal 15, the speed that you want to be traveling at, times the sine, the sine of t. So, geometry. So all you want to do is change your x by this amount, change your y by this amount, and you have traveled this speed in that direction, which is t. Now, I'm sure you're really excited by how beautiful that was, that you get to use some geometry. Now let's go back to your code and let's use geometry in your code. Now, I want you to get to the right spot. Don't be that kid that's like writing code out in wherever, outer space. I want you to, in your RingQuest, you already have some setup. Now, you've already put setup stuff there. I hid mine from you, so I'm not giving the answer. Cheater. So you got your setup going on. You set up your ring. You set up your Bilbo. Then I gave you this little comment called movement. Now, just like with Mario, anytime you make a move or make a change, you're going to have to draw everything again so you can see it. But here it comes. If we want to make some movement, we need to change. These are all your variables. These are important to me. This is important to me. Also, you have a variable called speed. You could use it if you want to. Now, let's just start simple. I need to change my player X. I want to add to it. Now, if I just did something like that here, let's go. Let's make it a little more dramatic. If I did this and then ran it, well, that happens too fast for you to notice, but that would move him up the screen and diagonal, right? Which is not exactly what I want to do. So what we want to do, let's say we liked that. Where was our picture? Let's say we really like this whole moving by 15 business. So we want to say that your change in x is 15 times the cosine of your direction. So let's just say 15 times math.cosine. By the way, that's a thing, math.cos. And we want your direction, which is player dir. So there's your angle. This is the speed you're going to be moving with, cosine. And then almost the same thing. Take a moment to make sure that you didn't have a copy paste fail. This is all the same except for sine. Now, again, it's hard to spot what's going on because it all happens so fast. Now, here's what I want you to do. And then I'm going to make you undo it, so don't get mad. Copy that. And you want move, and just like Mario's animation, move and draw, and move and draw. And let's just do that, I don't know, tons of times. Which is not what I'm going to make you change it, so don't freak out. Bueno. So, try that, and run it. And run it. Whoop. Now, just for fun, just to prove to you that this works no matter what, at the very in your movement, right before you actually start moving, and we'll take this out too. Let's see if it actually works for all directions. So let's point him 45 degrees. If I point him 45 degrees, does this make him move in the right direction? Nice. What if I made him do 5 pi over 4? 5 pi over 4 would be 5 pi over 4 would be I guess I should know that, way down here. So he should be going diagonally down to the left. Awesome. Right, so you just try out a few of these fun times. What if I said 3 times pi over 2? Does this work? Awesome. Now, so pause the video a little bit if you want to play with those things. That'll be awesome. Now, pause and play. Okay, now you're done playing. Let's let's take this out because you already have him pointing. I really want him to be pointed towards the ring, right? And spoiler alert, you already know this, you do not want to say the same thing a million times. That is silly. You don't want to do the same thing a million times. If you want to repeat those 3 lines of code, you're going to need a loop. So momentarily we're going to put a loop into here. So preview of coming attractions in the next video, you're eventually going to have some kind of loop that will repeatedly do these things. So that's the sandwich of your, or that's the meat of your sandwich. You're going to have a loop, which either a while or a for. We'll talk about that later. That'll be the top bun of your sandwich. This will be the bottom bun of your sandwich. These will be the fillings of your sandwich are moved over, and what you're going to want to eventually have is he moves and draws himself, and move and draw, and move and draw, and move and draw. And that'll be kind of in the next video. Stay tuned.